Alright, in this video, this is Chapter 1, Lesson 5. We're going to talk about negative exponents. Now, this video is not going to be as long or comprehensive as the one that I made for my 7th grade students last year. However, I will say, check out that video. I will put a link of it in the description. It will lead you to a more detailed video with tons of examples if you think you need more practice with this concept. But it's also a good review because it's also going to use your multiplying with exponents, like your product property. It's going to use your quotient property when dividing with exponents. So it kind of reviews all of it all in one. So if you think you need more examples to practice from to be able to check yourself and get feedback from, check those out. Alright, so our objective is going to be, as a student, I can write and evaluate expressions using negative exponents. So and this is going to be because we're going to apply the rule that we're going to talk about into working out sometimes some complex situations or some complex expressions or equations. We're going to be able to simplify them in a way that's more user-friendly. So to make this point, let me start by first establishing this to make a point. I want to ask you this question: how is 100 written as a power of 10? So, for example, if we were to write that as an exponent, that could be 10 squared. That would give us 100 because 10 times 10 is 100. So that's what I mean. Now, how about 1,000? Well, I see 3 zeros, so that's going to be 10 to the third power. Exactly. So maybe I'll be able to predict what 10,000 is going to be. It's going to be 10 to the fourth power. Now, just for the sake of argument, to make a point, if you had 10, how could we write 10 with an exponent? That's just 10. So that means we didn't multiply at all, so it's 10 to the 1 power. So I just kind of want to get you thinking about this whole exponent business because we can get things can get really big with positive exponents. But what we're going to talk about in this section is what about when we have negative exponents? So with positive exponents, we were multiplying. We were literally doing 10 times 10 times 10. But now, if we're going to do negative exponents, we're going to talk about what that means. So for example, if you were to do 10 divided by 10 divided by 10 divided by 10, things like that, that's what we're kind of going to talk about. So that's what this video is going to be about. What if we're going in the other direction, getting even smaller? So let's quickly run through some of these examples. Like I mentioned, we went in the other direction. I wrote them in this order so you kind of see. 10 to the third power is 1,000. Now if we were to divide that, what we learned about the quotient property, for example, 10 to the third power divided by 10, or otherwise 10 to the first power. We learned before, when you do the quotient property, we learned last year, and I gave you a crash course in the last video, was you subtract your exponents. So 3 minus 1, so that's 10 to the second power, aka 100. So essentially, every time you divide by 10, which we already knew, you're taking away a 0. So 100 divided by 10 is just 10 with 1 0, so that tells us 10 to the first power is 1. Now, if we divide by 10 again, we're going to be left with 1. Oh, and look, I gave away one of the rules that we need to know in this section, is anything to the 0 power equals 1, except 0. So 10 to the 0 power is 1. Now, I'll get back to that whole 0 exponent thing in a minute, but let's keep going. Let's divide by 10 again. 1 divided by 10, well, that's just going to be 1 over 10. Well, 1 over 10, that's known as 10 to the negative 1 power. Now, if we divided that by 10 again, we're going to have 1 over 100. Otherwise known as 10 to the negative 2 power. We'll talk about how to interpret those in a minute. And now, let's say we're divided by 10 again. We'd have 1 over 1,000. So I just wanted to kind of show you that the equivalent is 10 to the negative 1 power is 1 over 10, 10 to the negative 2 is 1 over 100, and 10 to the negative 3 is 1 over 1,000. And like I said, we'll go through some examples of how to find that on our own necessarily for any number, not just with 10. And of course, by the way, I will point out there are decimal equivalents of these. Like for example, this is 0.1, this is 0.01, and this is 0.001 because it's the thousandths location. Hey, we divided by 1,000. That's kind of how we know it. Alright, so zero negative exponents. Essentially what you need to know, the big summary for this section is kind of on the screen. Make sure you jot this down. It tells us any non-zero number, meaning anything besides 0. So positive number, negative number, it could be decimals, fractions, doesn't matter. Any non-zero number to the 0 power will always equal 1. Always. And by the way, the only exception to that is 0 to the 0 power. That equals 0. That's why they said non-zero number, because 0 is always, to anything is always going to be 0 power. Now, that's 0 exponents. Now, any non-zero to the negative n power is a multiplicative inverse of its nth power, aka the reciprocal. And we'll talk about what that means in, coming up right now. So let me give you a couple examples of that. So like I said, this whole 0 exponent thing, I'm not going to spend too much time on that. Essentially, anything negative a billion to the 0 power equals 1. positive billion 0.56 to the 0 power still equals 1, except for 0 to the 0 power. That equals 0. So I'm not going to spend too much time talking about that. So now let's talk about negative exponents. Let me give you an example, a quick example of that. Let's say we had 7 to the negative 4 power. What that means is, what we're going to do is we're going to, the reciprocal of that, because technically 7 is over 1, it's not necessarily going to be flipping it, but what we're going to do is we're going to take just that term, the 7 to the negative 4, we're going to move that to the other end of the fraction. That's how I like to describe it. So what we're really going to do is, that 7 is going to show up on bottom with its exponent, but now once we move it, its exponent will be positive. Because there's nothing left on top, we're going to put a 1 there, because there's nothing left. So we're not technically flipping, which we kind of do with reciprocals. We're kind of just taking that term. And I agree, when you have only one item, just a 7 and an exponent, it is essentially flipping. But if you had more terms, it won't necessarily be flipping. So what I mean by that is, would look like this. Let's say we had x to the negative 2 power times y to the 3rd power. If we have that, the thing that has the negative exponent is the x. So let's even say there was a coefficient in front of it. The 2 doesn't have a negative exponent, only the x does. The x has the negative exponent. So in this example, only the x squared is going to go to the other end of the fraction. So it's kind of over 1 right now, but that doesn't really, we don't really need that. But I just wanted you to see it's in the top of the fraction. If you don't see a fraction, everything's in the top because it's over 1. Anyways, that 2 does not have a negative exponent, so the 2 is still going to be on top. It's not going to be moved. The y has a positive exponent, so the y is not going to be moved either. So the y is going to stay where it's at, which is right there on top. But the x to the negative 2 power, that's going to move to the bottom. And once it does, it's going to have a positive exponent. So what I meant was, only the item that had the negative exponent, it was the x, not the positive 2 coefficient. Only the x had the negative exponent. Therefore, the x is the one who got moved to the other end of the fraction. Now, if that x had already been on the bottom of the fraction, it would have come to the top. Let's look at some examples. That'll help. All right, check out these 3 examples. We'll start off with 2 kind of simple ones and 1 slightly harder one towards the end. And 2, I'll even add a coefficient to that one. We'll put a 5 out there. Hey, and we'll put a 4 down here just to make a point. All right, anyways, let's start with the first one. X to the negative 4th power. Your instructions would say something like, let's say it said, rewrite this using a positive exponents only. So in other words, look for any negative exponents and move them so that we can make them positive. So we got x as a negative exponent, so that means that x needs to go to the other end of the fraction. It's currently in the top of the fraction, if you don't remember that. It's kind of over 1. So we're going to move it to the other end, which is the bottom. So that means x to the positive 4 is going to be on the bottom. Now, there's nothing left up top in the top of the fraction, so that means a placeholder is a 1. So that's going to be the simplified version with a positive exponent of that one. Now, let's go to the next one. 4m to the negative 5 power. Same exact thing, except notice, only the m has the negative exponent. The 4 doesn't, because it's 4 times m to the negative 5 power. Only that m has that. So that means, remember, we're technically in the top of the fraction currently right now, so that means that m is going to go to the bottom. But that 4 does not have a negative exponent. It's staying put. So 4 over m to the positive 5 power. That's going to be the simplified version of that with positives. Now, if you think you've got the hang of this one, try this third one on your own and hit pause and give it a shot. Alright, you'll notice that the 5x to the 4th power does not, none of those are negative exponents, so they're still going to stay right where they are. So on the top of the fraction. Now, that 4 in the bottom does not have a negative exponent, so that 4 is also going to stay right where it's at. Now, the y does have a negative exponent, so the y is going to move to the other end of the fraction, and it's going to now have a positive exponent. The z that was in the bottom had a negative exponent. We got to make it positive, so if it's in the bottom already, you're going to move it to the top. So z to the positive 3 power. So this right here is going to be our full simplified version of that question, rewriting it with positive exponents. Alright, so in these we're going to go in the other direction. Let's pretend we want the 4 seconds, or sometimes you're going to rephrase it and you want a negative exponent. So in these examples, the instructions are write each fraction as an expression using a negative exponent, but for the sake of making it interesting, other than negative 1. Because obviously you could easily move, for example, this middle one, 1 over 8, to just 8 to the negative 1 power. But other than negative 1, let's be creative. That's what we're going to do. Alright, so let's start with the first one. The first one, we'll start with an easy one. In the first one, we have 1 over 3 to the positive 4 power. We want a negative exponent, so we're going to move that 3 to the other end of the fraction. So that 3 is going to kind of go to the top since it's already in the bottom. But since we've now moved it to the other end of the fraction, its exponent is now negative. So we're going to have 3 to the negative 4 power. We're forcing the negative exponent. Now, let's take a look at this one in the middle, 1 over 8. Now, I don't see an exponent, but technically we know that there's a 1 right there. But we said we're going to be creative, other than 1. So try to imagine, it doesn't have to be a 2, it doesn't have to be something squared. Maybe it's something to the third power. And let's see, something to the third power. 2 times 2 times 2, oh, that's 8. Oh, okay, so 2 to the third power is 8. So we can think of that as 1 over 2/3. Now we can rewrite that with a negative exponent and move it to the top of the fraction where it's technically over 1, so it is in the top of the fraction, but we don't have to show that if there's nothing left on bottom. So 2 to the negative 3 power is going to be the way to write 1 over 8 purposely with a negative exponent. Now this last example, forcing it and giving a negative exponent, is going to be just like our last one. Now, being more exciting than trying to do something boring like 125 to the negative 1 power, they said other than negative 1. They want you to push yourself to try to think about exponents. Now, something to something power. Now, so let's see. 25 times 5 is 125. Okay, and 5 times 5 is 25. So we can think of this as 1 over 5 to the third power currently, because 5 to the third power is 125. So if we move it to the other end of the fraction, it's now on the technically top. I'm just not going to show that. And so that's going to be our final answer for that last one, 5 to the negative 3 power. So now I also want to make a point that the reason why we brought up this whole negative exponent thing is sometimes when we're using the skills we've learned before, such as the product property of exponents, or the division property of exponents, using these for those, or down here the product property again. For these questions, sometimes you're going to get answers with negative exponents in them, and when that happens, we want you to know how to handle them. We want you to know how to take your time and do them step by step. Now, for this first problem, z to the fourth times z to the negative 6. By the way, if you think you already know how to do these, feel free, press pause, knock these out, and then see how you did. So now, for this first one, I'm going to briefly describe it visually, and then I'm going to just kind of remind you of how we could have done it the old way. So, or I'm sorry, the new way, the fast way. So the visual way would z to the fourth power is z times 4, or excuse me, z times z times z times z, and now times z to the negative 6 power. Well, that means we have 6 z's on the bottom. I don't have room for all 6 apparently. So let's say all those z's times each other over 1. So we have these times each other. So now this is over 1. So when we multiply those together, we're essentially going to have 4 z's on top, and because remember, multiplying fractions straight across, and 6 z's on bottom. Well, that means what we're going to do is we're going to have to cancel. That one will cancel with this one, that one, and essentially you'll cancel 4 on top and 4 on bottom, but you'll notice you'll be left with 2 on bottom. So because of that, your answer is going to be 1 over z squared, with it being on bottom like that, which is also known as z to the negative 2 power. So that's actually going to be the answer to this question we're about to do. So let's go back to that example. We're going to do it the fast way. We learned crash course in our last video, when you multiply like variables like this, you add their exponents. So that means we're going to have 4 plus negative 6. Now you got to use your negative skills. That means add a negative, you go left, so you're like subtracting. 4 minus 6 is negative 2. So that means our answer is z to the negative 2 power. Now, preferably we should be able to write these as well with positive exponents, and z has a negative exponent, so it means it's going to the other end. So 1 over z squared. That's another way of saying the same thing, which is what we got down at the bottom when we did it visually. So now, so now what we're going to do is we're going to talk about that second example, is what we're going to do now. Alright, put the little divider in there. Okay, so when you have coefficients and you need to divide, feel free to go ahead and do the division. 12 divided by 3 is 4. And now we have dividing with variables. And so we learned before to subtract the exponents when you divide with variables. So negative 4 minus negative 3. So x to the negative 4. So negative 4 minus negative 3. Now, when you minus a negative, you got to remember your negative skills from 7th grade, is when you minus a negative, it ends up becoming adding. So what you really have is you have negative 4 plus 3, and that's going to be negative 1. So that's your x is going to be to the negative 1 power up here. 4 times x to the negative 1 power. So we could say that was our answer, but like I said, let's preferably get in the habit of writing these with positive exponents. So the x has a negative exponent. So that means the x needs to go to the other end of the fraction, which means it's going to the bottom. So 4 over x to the positive 1 power, or if it's the exponent's a 1, you don't really need it. So this would be the other way of saying the answer with positive exponents. That would be what we would have for the second example. Alright, and last but not least, let's knock out this one on the bottom left. If you think you already can do it, please hit pause and knock it out if you haven't done so already. Alright, so let's see. We don't have a coefficient on this one in the front, but we could pretend it's a 1. So we multiply these, we learned in the past video, we multiply the coefficients. So 1 times the other coefficient of 2 is going to give us 2. Now for the w's. We're going to have w to the, we're multiplying, so we're going to add the exponent. So negative 4 plus negative 7. So you got to remember your negative skills. Anytime you add a negative, you end up going to the left. So you're essentially going to go deeper into the negatives. So negative 4 kind of minus 7. You go deeper in the negatives, you're going to be at negative 11. So 2 times w to the negative 11 power. That's one way of writing this answer. Or, let's write it with a positive exponent. Let's leave 2 in the top of the fraction, but let's move w to the bottom so its exponent can be positive. So these are the two ways to write the answers for that last example. So you've now seen how to handle negative exponents. You've learned about what happens if the exponent is 0. So now I want you guys just to make sure you have all this written down. Hit rewind if you need to, and then come into class ready to put this into practice.